So this is here for Chapter 2, Lesson 5 on proving angles that are congruent. We have two definitions. The first thing is something that I have been talking about. It's called a theorem. And a theorem is basically just a conjecture that's proven true. So we're going to make basically a hypothesis about something, and we're going to prove it to be true. And we're going to do that through a proof, which is a convincing argument that uses deductive reasoning. So we'll go over and we'll see what proofs look like here later on today. So, a little cool hands-on activity. It is quick, but it's kind of cool. Go ahead and on your piece of paper, draw two lines that make some kind of an X. Now your X could look like this. It could look like a traditional X. That's interesting. It could look like that. It could be, really wide. Doesn't really matter. But draw an X of some kind. And I'm going to have you do this. Label your top part 1, and then go clockwise around 2, 3, and 4. And I'm going to tell you right now that the measure of angle 1 is equal to the measure of angle 3, no matter how you drew your X. And also the measure of angle 2 is equal to the measure of angle 4. No matter how you drew your X, I'm going to bet that that is going to be true. And what I'm going to have you do is I provide you with a protractor. Go ahead and measure angles 1, 2, 3, and 4 and see if I'm right. This leads us here to the vertical angles theorem. And that means that this theorem 2.2-1, the vertical angles theorem, says that vertical angles are congruent. Now with theorems and stuff, I'm not going to be so worried about this is theorem 2.1. We're going to be calling it by its name, the vertical angles theorem. You're not going to hear me say, well, by theorem 2.1, this is true. No, we're going to be saying with the vertical angles theorem. So this says that vertical angles are congruent. In this case, they numbered it 1 and 2, and 3 and 4 were opposite. So they're congruent, which means that their angle measures are the same. We'll look at how to prove that here in just a little bit. Alright, so let's say that I want to use this. We're going to find the value of x. So because these two are vertical angles, 4x and 3x plus 35, then that means that they are congruent, which means that their angle measures are the same. So I know that 4x is equal to 3x plus 35. So to solve for x, then I can just subtract 3x from both sides. And we get 1x is equal to 35. And that's it. That's how we can use the vertical angles theorem. At least for right now. We'll be able to use it in more complicated ways in a little bit. So here we have theorem 2.2, which is the congruent supplements theorem. And because truly, the vertical angles theorem is actually just a special case of the congruent supplements theorem. And what this congruent supplements theorem tells us is that if you have two angles and they're supplements of the same angle, or of congruent angles, then those two angles are congruent. And I know that made probably absolutely no sense to you whatsoever. It didn't really to me the first time that I ever heard it, so I have this example down here. If two angles are supplements of the same angle, so A and C are both supplementary to B. So A plus the measure of angle B plus the measure of angle A is 180, and the measure of angle C plus the measure of angle B is 180, then A and C have to be congruent. The reason why we do have this first theorem here, the vertical angles theorem, is because we're going to probably end up using this a lot more than the congruent supplements theorem. Not that this isn't useful, but so you got two sets of supplementary angles, and then we know that one of those pairs has the exact same angle. So then we have three others in this chapter, this section. We have the congruent complements theorem, And that basically says the same thing back over here with the congruent supplements theorem, except it's with complementary angles. So it's the measure of angle A plus the measure of angle B equals 90, and then the measure of angle C plus the measure of angle B equals 90. So then the measure of angle A and the measure of angle C is the same. They are congruent. All right angles are congruent. So no matter what kind of right angle you're going to have, it's going to be congruent. And then if two angles are congruent and supplementary, then each is a right angle. So that's saying that we got two angles, they're congruent, they're equal to each other, and they're supplementary, so they're both adding up to 180, then each one is a right angle. So we're going to look here about how we can prove the vertical angles theorem. And your book for this section does a paragraph proof for this. We're really only going to look at one type of proof, and that's called a statement reason proof. Paragraph proofs are nice, but they're often overly complicated for no real reason. So we're going to stick with the statement reason proofs, which will kind of impact your homework just a little bit tonight, but not too much. So let's take a look at the statement reason proof for why the vertical angles theorem is true. So we have this drawing here. We got two vertical angles, and we want to prove that those two vertical angles are congruent. And we're going to start off with here, the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. And we know that because of the angle addition postulate. So we have that. And then we try to think, okay, so again, I'm trying to show that 1 and 2 are going to be equal to each other. The measures are equal to each other. Well, I also know that 3 and 2, those two are also going to have to add up to 180 degrees because those are also supplementary angles. So by the angle addition postulate, these two are also going to add up to 180 degrees. So next, we can use substitution. We know that the measure of angle 1 plus the measure of angle 3 equals 180. The measure of angle 2 plus the measure of angle 3 equals 180. These both equal 180, so they both have to equal each other. So that's by the substitution property. And now I can subtract the measure of angle 3 from both sides. And we can do that by the subtraction property of equality, which gives us that the measure of angle 1 is equal to the measure of angle 2. Thus, angle 1 and angle 2 are congruent. So that's the proof for why vertical angles are congruent. We are going to look at one final one here together in class, but that's the brief little overview here of Chapter 2, Section 5.